I'm going to show you how I forged a high-end kitchen knife from a bunch of twine and a chunk of steel. This is W1 steel. Welcome back to the shop. Glad you guys could come along. You'll probably see a lot of integral knives made from W1, and I think the main reason is because W1 is often available in larger round dimensions, unlike many other steels. This one is 1.25 inch diameter, which admittedly is probably at least 1/8 of an inch bigger than I really needed for this project. But I found this at McMaster Car and got some of this, so I was excited to try it out. The last time I used W1 steel was on Forged in Fire when Jay Nielsen stabbed my knife through a ammo can multiple times. And I was just using a forge for the heat treat in that scenario, and found it to be pretty decent steel under the circumstances. And so we're going to go ahead and make another knife out of W1 steel. You see, the process that I'm trying to do here is forge an integral knife, which means the blade, the bolster, and the tang are all forged from one piece of steel. And then of course your handle material is an additional component. Something that's always intrigued me with integral designs is the fact that theoretically you could basically make a knife from just two pieces of material, such as a piece of steel, a chunk of steel, and say a piece of wood or a piece of antler, or in this case a length of jute twine. One of the challenges with an integral is to maintain the shape of the bolster while forging out the blade. Now the power hammer did come in handy. I was back and forth with different forging, I guess, techniques or movements here, you know, between lengthening it out, widening it out, back and forth a little bit, and then, you know, cleaning things up like the bolster here. Overall, I was able to get the width that I wanted on this blade, which I guess is one advantage of the slightly larger round cross section. So this is what it looks like out of the forge. Spent a fair amount of time straightening it and making sure that the tang and the spine line up straight, but they're also in line side to side. Just a quick cleanup on the profile with the grinder. Did not grind the bevels or anything. And we ran normalizing and grain refinement cycles, of course, a couple of those, and into the quench. W1 is not a deep hardening steel, so it requires at minimum Parks 50 for adequate hardening or proper hardening. And interestingly enough, you see the difference in the cross-sectional thickness of the bolster versus the blade. The bolster did not harden fully in this case, which I would not expect it to. That would actually require a water quench. As the steel designation suggests, W1, it's a water hardening steel. The thin cross section of the blade will harden adequately or properly in the Parks 50. So just roughing off some of the material from the bolster. I had a lot more than I needed to on there. Something to pay attention to in the future, I guess. Just wanted to be able to have room to make some nice, crisp, obviously 90-degree shoulders on there. So remove some of that material, and of course the tang is also longer than it needs to be. So then I went to my carbide file guide once I had some flat surfaces on either side of the bolster, and that worked pretty well. I'm sure there's a better way to do it. Alright, so there it is out of the grind. Got a lot of hand sanding to do on this, and I don't know, we'll see how this goes. But I did get the end of the tang here, and I'm going to run this into the hardness tester, and we'll test this part because I've got flat surfaces here, and we'll get an idea of the hardness of our blade. So this might not be the best specimen, and technically you need to have several tests on the same piece to get a really accurate reading. You take the average of like 3 different tests, but this will give us, should be within about a point. This will give us an idea. So we'll wait for the needle to stop moving. Usually takes a little bit of time. And all right, so we're reading 61.5 HRC. That's great. That's what I would expect it to be, and I think that's a good hardness for this steel and this application. Could be, you know, it could be another point higher, maybe 2 points even, but I think 61.5 is respectable. And like I say, we're still, you know, it's within a point anyway, so I think that's good based on the test sample and all the variables. I did finally take the time to get the hardness tester set up and calibrated. Really was not as bad as I thought it was going to be. You'll be seeing more of that in the future on some other projects I have planned here. So after a bunch of hand sanding and trying to pay attention to just the overall fit and finish, I went up to 220 grit on the knife. In hindsight, I should have done the blade and the bolster radius, you know, up to 600 or 800. But we've got a twine wrapped handle on there, and I'm using fiberglass resin, which has a resin component plus a hardener, and after an appropriate amount of time, it hardens right up. You've got a nice solid chunk of material there. What I did not realize was that the resin has a shrink factor, and so while I had the twine and resin combination nice and tight up against the bolster, and in this case actually over it, once I got down to the bolster there was a gap because the whole thing had shrunk, and that was also evidenced by the tang sticking out at the end ever so slightly as well. But this works out pretty much like wood if you're shaping it. There you go, there's the nice gap, the nice consistent gap. That whole thing just shrunk right back off of that bolster there, so we're going to have to fill that in now. To fix this gap, I'm just going to repeat what I already did on a much smaller scale, however, and that is use some kind of adhesive, in this case super glue, and some more twine to build a handle in that spot. So minus the shrinkage, the idea of building a handle onto your blade is, in my mind, kind of a neat idea. Obviously, there's some issues with it, but I guess if you can factor in the gap or the shrinkage somehow, that would be all right. I spent quite a bit of time filing and then sanding the facets, the handle, and of course the blade. Went up to an 800 grit hand finish on this, and it does hand sand quite a bit easier than the 50-100 steel that I'm used to working with. Alright guys, wrapping this project up. It turned out pretty cool. The next thing is to put an edge on it and show you guys pictures of the entire build, which I haven't taken yet. But if you enjoyed this project, don't forget to subscribe to see more cool content like this. I still really love the idea of basically a two-piece knife. It's just a cool concept to me, and hopefully it was helpful to you in that regard as well, inspiring and giving you some tips in your own shop. If you want a t-shirt, the link is in the description below. As always, appreciate you guys watching, and we will see you on the next video. All right, I know somebody's gonna ask for a paper cut. Does that sound right? All right. I mean, like, you know, the knife. Okay. Pretty sharp.